Okay, so we looked at how to write the line structural formulas, the condensed and the expanded structural formulas given the name of an alkane. Okay. All right, conformations are basically arrangements. All right, so the arrangements of these atoms in space, those are known as conformations. Remember, the single bonds means it's a free rotation. All right, so it's freely able to rotate between these carbons. And so sometimes this group is up together like this, or one is up and one is down because of the fact that the single bonds allow for free rotations. All right, and that can lead to several types of arrangements, and all of these arrangements are called as conformations. All right. So butane, for example, if you write it flat like this, the expanded structural formula, and then you can write the condensed structural formula in several ways. Okay, you can write them all in a continuous chain, all in a straight line, or you can have it zigzag like so, or you can have it like from top to bottom like so, or you can have these two like this, um, kind of forming like an L shaped and then one coming down, or you can have it kind of like an open square type of shape, and so on. Okay, the most important thing is it doesn't matter how it's written, you want to look at the continuous chain, all right, the unbroken chain of carbons attached to each other. All right, that tells you the number of carbons in the compound. Okay, the parent compound, so to speak. And then you have another group of alkanes called as cyclic alkanes. So as the name implies, there's a kind of a cyclic structure here. All right, so this is propane. All right, these carbons are kind of connected by single bonds, but there's no kind of ring structure. All right, so just single bonds between the carbon atoms. Whereas in cyclopropane, you have a ring structure, kind of a triangular structure. All right. So these two carbons at the end in propane end up losing two hydrogens each and connect to each other through this ring. All right, so you need at least a minimum of 3 carbons to form a ring structure, a cyclic alkane. Okay, so cyclopropane is the first of the cyclic alkanes. Okay, now, when these carbons are attached to each other in a ring structure, remember carbon has 4 bonds, so each carbon is already forming 2 bonds with its neighbor, on either side. Therefore, each carbon can only have 2 hydrogens. All right, so the number of hydrogens is reduced. All right, in an alkane, if you look at the number of hydrogens, it's twice the number of carbons plus an extra 2. All right, so if n is the number of carbons, okay, so n is equal to 3, so 2 times 3, that's 6, plus 2. So the number of hydrogens can be calculated using the formula 2n plus 2 for an alkane. Okay, whereas for a cyclic alkane, it is 2n. All right, so if the number of carbons is n, which in this case for cyclopropane is 3, so twice the number is 6. All right, so 6 hydrogen. All right, so in the non-cyclic alkanes, it's 2n plus 2, whereas for the cyclic alkanes, the number of hydrogens is 2n. So you see here some of the cyclic alkanes like cyclopropane, cyclobutane, cyclopentane, cyclohexane. All right, so they kind of have these Greek names. The prefix is always cyclo and end in ane, showing that all the bonds are single covalent bonds. Okay, So the cyclopropane has this triangular structure, cyclobutane a square, cyclopentane like a pentagon, and cyclohexane hexagon. All right, so these are the line, or sometimes they're also referred to as the geometrical formulas, okay, because the shapes are geometrical. The key to remember that each carbon has two hydrogens, all right, because of the cyclic structure. All right, given the IUPAC name for each of the following compound, give the IUPAC name for each of the following compounds. All right, so let's count up the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8. So this is octane. This is cyclic, all right, and you have 5, it's a pentagon, so cyclopentane. Name the following alkanes. All right, so again, just count up the number of carbons: 1, 2, 3, 4. So butane. This is a cyclic compound, 3 carbons at each point, so cyclopropane. Okay. Here in this expanded structural formula, you have 3 plus another 3, 6, 7, 8, so octane. Again, this is a cyclic structure. Each point signifies a carbon, so 6 points, so it's cyclohexane. Okay. All right, coming to section 12.3. You're looking now at alkanes with what are called as branches or substituents, all right? So you have a straight continuous chain and then you see a branch coming off of it, okay? And what does that look like, right? So you see that you have one continuous chain of carbons. This is 1, 2, 3, 4, so butane. But then you have a continuous chain of carbons like here, propane, but then you have a substituent or a branch coming off the middle carbon. All right, so you'll represent it this way here in the condensed structural formula, and the line formula looks like this. Okay, and this is the line structural formula of butane, right? So what are you doing here? So both have got 4 carbons, all right, C4. If you count up the number of hydrogens, they match, all right? It's 4 times 2, that's 8, plus 2, 10, all right? So butane is C4H10. They have the same molecular formula, C4H10. However, the arrangement, the groupings of the atoms are different, all right? You have a long continuous chain here for butane, the zigzag shape like so. And then the shape of this other compound is different, all right? The long continuous chain is propane. And then it has this group of CH3 that comes off the middle carbon, all right? The middle carbon does not have 2 hydrogens. It has only 1 hydrogen because carbon can only have 4 bonds, so it has only 1 hydrogen, right? So basically, if I took away the CH3 over here, right, brought one of the hydrogens over there, that would make this CH3, all right, and I would place that CH3 over here after pulling out one of the edges, okay, and that gives me this branch, okay. The way this is named is this is like methane, okay, but methane without 1 hydrogen, that's CH3, and therefore that branch or substituent is called as methyl, YL, all right? So methane, ane becomes YL when it is 1 short of a hydrogen, all right? So this is named as propane, the parent chain, the continuous chain. At the second carbon, you have this methyl group. So 2 hyphen methyl propane is how you would name that, okay? All right, so when you have 5 carbons, again, you can arrange them in 3 possible ways. So these 2 possible arrangements of 4 carbons, these are called as structural isomers, same molecular formula but different arrangements of the atoms. Okay, so what are the structural isomers of pentane? Okay, so you can have a long continuous chain that would be just pentane, and then you can have pentane with a branch. Okay, so it looks like this. Okay, so you long continuous chain, that is just the normal pentane. Sometimes it's abbreviated as N hyphen pentane, normal pentane. Okay, and then you can take the CH3 and bring it either to this spot or this spot. All right, and then shorten that chain to 4 carbons like here. Okay, whether you bring it here or here, it's the same thing. Okay, and so this becomes the second carbon. All right, you can either name it left to right or right to left, makes no difference. So this is if it was here, you would start numbering the carbons left to right. Okay, I'm sorry, right to left. Okay, so you want to give the branch the smallest possible number. So you place it here on the second carbon. So the long continuous chain is butane. At the second carbon, you have this methyl group. So two methyl, um, two hyphen methyl butane. Okay, between a number and a letter, you have to have a hyphen. Okay. Now you can also take this particular CH3, take out this hydrogen, bring it over here, and now the long continuous chain is reduced to 3 carbons, all right, with 2 branches coming off that middle carbon. So it becomes propane and 2, comma 2 and hyphen dimethyl propane. All right, we'll come to the naming a little bit later on. I just wanted to go over how the arrangements are going to be. Okay. All right, so those substituents, if it is coming from an original alkane with missing one hydrogen, then the substituent is called as YL, alkyl. All right, methyl, ethyl, and so on. Okay. If the substituent is a halogen like fluorine or chlorine or bromine or iodine, then the substituent names are fluoro, chloro, bromo, iodo, and so on. Okay. So if the substituent is a CH3 group, it is called as methyl. If it is CH3CH2 ethyl, 3 carbons, propyl. All right, so instead of propane, propyl. Instead of ethane, ethyl. All right, now if the branch is at the end of those 3 carbons, it's propyl. If it is the branch point is on this middle carbon, it's called as isopropyl. Okay, and then you have butyl, 4 carbons. If you have a branch point somewhere in the middle, secondary butyl. If you have a branch point like so with the 3 CH3s around a middle carbon, tertiary butyl, and then isobutyl kind of looks like this. And then you have fluoro, chloro, bromo, and iodo, which are the halo substituents. Okay, so how do you name alkanes with substituents? Look for the longest continuous chain. Number those carbon atoms starting from the end which is closest to the substituent, because you want to give the substituent the lowest number possible. So then give that location name for that substituent, and then you're going to name the substituents in alphabetical order. Okay. So here you have a substituent, the long continuous chain. Whether you go from here to from left to right or right to left makes no difference. It's in this middle carbon. So 1, 2, 3, 4, 5. Pentane is the parent carbon. On the third carbon, you have this methyl group. All right. So 3 hyphen methyl pentane. Oh, oops, I'm sorry. there is a chloro on the second carbon. We'll stop here.